We started with a simple idea, to build our own coffee roaster from the ground up. Using Fusion 360, we created a detailed 3D model to visualize how everything would fit together, from the airflow paths to the mounting points. We followed that up with a 3D printed prototype to get a hands-on sense of the design before committing to full-scale fabrication. Once the design was locked in, we got to work cutting metal and welding the pieces together. It was a long process, but it was important that we kept the design true to the model so airflow and heat transfer would function correctly. Both are critical for consistent roast. With the physical build complete, we moved on to wiring the control system. We used fidget models for temperature sensing, fan speed control, and data feedback. This gave us real-time control and automation over key variables and made it possible to fine-tune the roaster's performance. After some testing and adjustments, we were able to hit and hold the exact temperatures needed to roast coffee beans consistently and effectively. Here is the block diagram for our project. First, we'll take a look at the fan control loop. The thermocouples send temperature data through the Fidget's hub to the Raspberry Pi, where Artisan calculates the required fan speed. That signal is then sent back through the hub to a stepper motor controller, which adjusts the stepper motor connected to a potentiometer. This controls a solid-state relay that regulates power to the fan. The fan keeps the beans lofted at the right height, allowing heated air to circulate evenly around them during the roast. Next, you will see the blower motor we have chosen for our roaster. Next, we'll take a look at the cold air intake loop. Thermocouples send temperature data through the Fidget hub to the Raspberry Pi, where Artisan checks if the internal temperatures is too high. If it is, a signal is sent back through the hub to a stepper motor controller, which adjusts the cold air intake door. This protects the fan's electronics and burner wiring from overheating. At the end of the roast, the door fully opens to allow the roaster to begin cooling as soon as the beans are dropped. And finally, the heat source control loop. The thermocouple measures the bean temperature and sends that data through the Fidget's hub to the Raspberry Pi, where Artisan, using a PID controller, checks if the roast is tracking our target heat curve. If it needs adjustment, a signal is sent back through the hub to a servo controller, which drives a servo motor connected to a potentiometer that adjusts the power to the burners. This feedback loop keeps the heat within tolerance. Up next, you'll see pictures of our burner setup and how they look like when they're running.
Hey guys, today we are here with the RoastBusters. What you're going to see here is our roasting profile. Going around, you will see our looking glass window. We currently have a light on it so that you can see in it. Here is where the beans will come out of the chamber when they're done cooking. Up top is where the beans are actually added. Coming around to the back, you will have the electronics box with all of our electronics and programming, our power supplies, buck converters, things of that nature, with a fan to cool them to ensure they don't get hot. We'll come around this way. You will see a chaff collector bag. The next box is going to be for smoke filtration. And finally, a fresh air intake that's controlled by a stepper motor. We are going to start Artisan. And you will hear the fan come on, and then 10 seconds later, the burner will come on. Once this reaches 150 degrees, you will see the beans being added into the chamber. 150 degrees, the beans are going into the chamber. What you will see here is the beans wafting around. It will be tracking on the Artisan profile, and once it's complete, we will show you the beans coming out of the chamber.
In this time lapse, you can see the PID controller in action. The red line shows how I adjust the power to the heating element, working to keep the blue temperature curve as close as possible to the background profile. The PID is set to turn on automatically at charge right after the beans are added and shut off when the roast ends, so the heat doesn't continue after the drop.
So now that we have reached 436 to 437 degrees, the beans are done. You'll see them here, they're now a dark brown color.